So it's supposed to be 6, 9 here.
So if we're asked to find the area of a regular hexagon, and all of these side lengths are 8, in this problem, all of them are 8.
Wait, do you say ours are 6?
You leave yours how they are. Okay, with a side length of 8, I know a couple of things, hopefully, about my hexagon. Number 1, a hexagon is made up of 6 equilateral triangles. Okay, this is only good with a hexagon as we have a bunch of equilateral triangles. Okay, whose radius is the same as the side length. Because, of course, in an equilateral, all sides are the same. So we could do something. We could find the area of the hexagon with a side length of 8. And then we can subtract off this regular triangle on the inside with a radius of 8. Okay, we would have to, of course, figure out what the side length is or use the regular polygon area formula. But we're going to work smarter than that because there's something else that we know about this triangle. So for our hexagon, each one of these interior angles is 120 degrees. Okay, according to the polygon thingamajobber, 8 minus 2 times 180 divided by 8 is how we find the interior angle of any one of these angles. Well, there you go.
So we would do 6 times.
So we would do all that, and you get 120 degrees as the measure of that angle. Now, I'm going to use a trig triangle formula, which says the area is 1/2 of any two sides, side 1 times side 2, times the angle in between them, or rather the sine of that angle.
Where are you getting this?
This is the trig formula that we use to find the triangle area if we know two sides and the angle in between them. Sorry, that's not 1/8, but rather 1/2. 1/2, we have a side length of 8, another side length of 8, and the angle in between these two is 120 degrees. Okay, I plug all this into my calculator and get equals 27.7 feet squared. Okay, so rather than having to find the whole entire hexagon and subtract off that triangle and divide it by 3, I just find the area of a triangle straight away.